In this video, we're going to continue to graph quadratic functions, but in two different forms, vertex and intercept form of a quadratic function. Vertex form looks like y equals ax minus h squared plus k. So it's this first form here that we're going to really focus on in this particular video, although I'll define both of the forms and the characteristics of each. If you're graphing from vertex form, the beauty is you can just look at the equation and determine the vertex. The vertex is at h, comma, k, which you can find just by looking at the equation. H can be found by the number that's being subtracted from x in the binomial that's being squared, and k is the number that's on the outside. This is very similar, by the way, if you recall when we had absolute value functions that were y equals a times the absolute value of x minus h plus k. If you recall the absolute value functions, the vertex was also at h comma k. So if you remember that, this form is going to be easy for you. The axis of symmetry is just the vertical line x equals h. It's going to go right through the x coordinate of the vertex. The intercept form of a quadratic equation looks like y equals a times x minus p times x minus q. The intercepts are going to be at p and q. And we'll talk a little bit more about what that means to have x-intercepts at p and q when we talk about those examples. But for right now, let's move on and talk about the axis of symmetry for this graph. The axis of symmetry is halfway in between those two intercepts, which are at p, 0 and q, 0. For both forms, the graph is going to open up if the a value is bigger than 0 and down if the a value is less than 0. In this first example, we're going to take a look at graphing a quadratic function from vertex form. If you recall, vertex form from the previous slide looks like a times x minus h in parentheses squared plus k. The first thing that I would want to do when I'm trying to graph from vertex form is identify what the h and the k values are. Remember, I said h is what is being subtracted from x. If you look here, we're not subtracting apparently anything from x until you consider x plus 3 to be exactly the same as subtracting a negative 3 from x. Recall, if you subtract a negative, that's the same thing as adding the opposite. So it's the same as x plus 3. So that tells me my h value is really negative 3. Now I'm going to try to find my k value, which is going to be 4. That's just a little bit more straightforward. Is what you see is what you get. That's that value up there. So I know right now my vertex is at negative 3, 4. By the way, just as a side note, you might recall when we graphed from those absolute value functions, the short way to get your h value, which is the trickier one, is just to know it's going to always be the opposite of what you have in that binomial. So if you see an x plus 3, you're thinking, all right, h value is negative 3. That's what I know a lot of students just remember it as. Now let's plot that vertex at negative 3. So we're going to go back 1, 2, 3, and then up 1, 2, 3, 4. So we're looking at this point for our coordinate, or our vertex rather. Now remember, our axis of symmetry is going to go right through that value. So I'm going to just kind of dash a vertical line right through it to help guide the rest of this graph. To get the rest of this graph going, I'm going to do something we did when we graphed from standard form, and I'm just going to make an xy table and pick some easy x values to plug in. Now I want to pick x values that surround the axis of symmetry. So I might choose negative 2, I might choose negative 1, or I might choose, what is this, negative 4, or negative 5. I already know what's going on when x is negative 3. I have a y coordinate of positive 4. Let's try plugging in something close by like negative 2. If I were to substitute in negative 2, I have to calculate negative 1/2 times negative 2 plus 3 squared, then plus 4. If I simplify using the order of operations and work inside the parentheses there, I'm going to get negative 1/2 times 1 squared plus 4. I know 1 squared is 1, so ultimately I get negative 1/2 plus 4, and that's going to be equal to, what, 3.5? So I know I'm going to get 3.5. So I know when I plug in a negative 2, I get an output of 3.5. Let's graph that point. So negative 2 and 3.5, right about here, if I can get this thing to work the way I want it to. Now, using symmetry, I can plot the same point that is 1 unit away from the axis of symmetry, but on the left side. So that would be that point. So I get that coordinate for free, really, just using symmetry. Let's plug in another x value. I already know what I get when I plug in negative 4, I get that. Negative 3, I get 4. When I plug in negative 2, I get 3.5. Let's plug in negative 1. If I substitute in a negative 1, I'm going to get negative 1/2. Let's zoom in a little bit. And then I'm going to have times, in parentheses, negative 1 plus 3 squared, then plus 4. If I simplify inside the parentheses there, this is going to change to negative 1/2 times 2 squared plus 4. And I know 2 squared is 4, so I get negative 1/2 of 4 plus 4. Negative 1/2 of 4 is negative 2. And if I add 4 to negative 2, I end up with an output of positive 2. So at the end of the day, when I substitute in 1 for x, my output is a positive 2. Let's see if we can plot that point correctly. If I substitute in a negative 1, I got a positive 2. That is this coordinate. And if I use symmetry, going 2 units reflected over the other side on the left, I would get that coordinate. Now I'm ready to draw my parabola. It's going to be a smooth U-shaped curve that goes through these coordinates, so something like this, and then likewise going in this direction, like that. By the way, a value, negative 1/2. Remember what we said about negative a values, that they open down. One of the easiest things you can check after you get done graphing is just to make sure you at least have the thing opening down. That might help you with finding an error when you substitute in a coordinate and plot some points. Let's do one last example for this particular video. We're going to look at one more in vertex form. Let's see if we can get right to the h plus k. Okay, let's get the h and k value. My h value is what is being subtracted from x. In this case, I'm subtracting a 3. You can also say, ooh, if I see an x minus 3, I know my h value is really positive 3. K value is negative 2. What I see is what I get. That gives me a vertex at 3, negative 2. Let's plot that guy. So 3, negative 2, right about there. Let's put in our axis of symmetry right away. If I can do this right, let me undo that. I don't like how that happened. Oops, bad aim here. Let's see if I can do this one more time, but this time accurately. That'll work. Pretty close. Let's get back to it. Now I'm going to try to shape this a little bit better by picking a couple x values to plug in. Surrounding the axis of symmetry are the x values of 2 and 1. So let's try doing that. I'm going to plug in 2 first, and if I do, I'm going to have 2 times 2 minus 3 squared minus 2, and that is going to be 2 times 2 minus 3 is negative 1 squared minus 2. Now I have to square the negative 1, which is really positive 1. So I have 2 times a positive 1, which is just 2. Take away 2, and I get a 0 output. So 2, 0. So 2, 0 is right. Let's see if I can plot this point right there. If I go 1 unit to the right of the axis of symmetry for free, I get that coordinate to plot. Let's do one more coordinate like x equals 1. If I plug in 1, I'm going to get 2 times 1 minus 3 in parentheses squared, then take away 2. Working inside of parentheses, I get 2 times negative 2 squared minus 2. If I square that negative 2 times negative 2 is really positive 4. So 2 times a positive 4 minus 2 will become 8 minus 2. In other words, oops, you can see I'm thinking ahead of myself. 8 minus 2 is 6. So I can plot the point 1 comma 6 here. So 1, 6 is right about there. Bad aim, a little bit off. And the stylus is challenging me. And for free, if I go 2 units to the right, if it will let me actually plot this point without doing something else, there we go. I'm ready to draw my smooth U-shaped parabola. Now this is going to be a little bit challenging. I'll try my best here. It's going to look something like, whoa, coming down. Try to make it a smooth transition on the bottom. A lot of students will down here make it like a sharp edge, like almost like an absolute value function. You want to not have any sharp corners on your parabolas. Try as much as possible to have them kind of rounded the way I have that rounded. And there is our graph. Notice a value positive 2, it opens up, and the larger the a value, the narrower it is, and that's what we have. Thanks for watching. Hopefully you have a good idea of how to graph a quadratic function from Vertex Form.